All right. Welcome back. So today we're going to do Advent of Code day 16. Yeah, wow. It's really getting on in the month. It's amazing how time flies when you're doing Advent of Code. Okay, so let's get started taking a look at 16. Day 16 is ticket translation. Okay. As you're walking to get yet another connecting flight, this is a lot of flights. I'm not sure where we're going. It's like one of the lesser known Pacific Islands, maybe? I don't know. You realize that one of the legs of your rerouted trip is coming up on a high-speed train. That's very cool. Okay, however, the train ticket you were given is in a language you don't understand. You should probably figure out what it says before you get to the train station after the next flight. I mean, yeah, that's a valid strategy. Unfortunately, you can't actually read the words on the ticket. You can, however, read the numbers. So you figure out the fields these tickets must have and the valid ranges for values in those fields. Okay. You collect the rules for the ticket fields, the numbers on your ticket, and the numbers on other nearby tickets for the same train service via the airport security cameras together. Wow, that's a neat trick. Together into a single document you can reference in your puzzle input. Okay. The rules for ticket fields specify a list of fields that exist somewhere on the ticket, and the valid ranges of values for each field. So for example, a rule like class 1 to 3 or 5 to 7 means that one of the fields in every ticket is named class and can be any value ranges 1 to 3 or 5 to 7 inclusive, such that 3 and 5 are both valid in this field, but 4 is not. Okay, so each ticket is represented by a single line of comma separated values. The values are the numbers on the ticket in the order they appear. Every ticket has the same format. So for example, consider this ticket. Here, question mark represents text in a language you don't understand. The ticket might be represented as 101, 102, 103, okay. And of course, the actual train tickets you're looking at are much more complicated. In any case, you've extracted just the numbers in such a way that the first number is always the same specific field, the second number is always a different specific field, and so on. You just don't know what each position actually means. Okay, so start by determining which tickets are completely invalid. These are tickets that contain values which aren't valid for any field. Ignore your ticket for now. So for example, suppose you have the following rules or the following notes. So class can be that, row, seat, your ticket, nearby tickets. Okay. So it doesn't matter which position corresponds to which fields. You can identify invalid nearby tickets by considering only whether tickets contain values that are not valid for any field. In this example, the values on the first nearby ticket are all valid for at least one field. This is not true of the other 3 nearby tickets. The values 4, 55, and 12 are not valid for any field. Adding together all of the invalid values produces your ticket scanning error rate. Okay, so 4 plus 55 plus 12 is 71. Okay, so you add up the invalid values. Okay, consider the validity of the nearby tickets you stand. What is your ticket scanning error rate? So that's a really interesting problem. This should be a lot of fun. Okay, cool. Let's get started. So we're going to create a folder, day 16. Here we go. And we're going to create a file. There we go. And we're going to make, there we go. So we've got some plain sections. It'd be really cool if the input was like this and we had to scan it. I guess we could just look for groups of numbers, but that would have been neat. Maybe it's unnecessary. I guess we can take all this as one big plain text block. Okay, cool. So this is going to be. So we're going to have rules and an input. So should we be hard coding the rules or should we be parsing the rules? I guess that's the question. What we should do The following notes. What is our puzzle input like? Aha, okay, so we will be parsing this entire thing as input. So that's good to know. So we're gonna have a rules section, we're gonna have a your ticket section, and we're gonna have a nearby ticket section. Cool. So I guess this is gonna be our input. And then we can, there we go. Okay, so we're gonna have the usual sections. We're gonna have definitions. We're gonna have, this is where we define, functions or classes or whatever. We're gonna have our test section where we prove that it works against the input, and then we're gonna have the run section where we actually just get the answer. So how are we gonna go about this? We're gonna need to parse rules. We're gonna need to, we could ignore our ticket for now, I think, because they just care about the nearby tickets. Invalid nearby tickets. Okay. And then we want to apply rules. So that's interesting. So rules are always groups of ranges, it looks like. We could parse this. We could be really naive about this on the first pass, because we can just construct ranges and apply the ranges to everything. Mind you, I guess we would need to apply this set of rules separately from this rule, separately from this rule. But I just know we're gonna have more stuff later where we're gonna have to be a bit more specific about our input. So we may as well write the parser now. So, okay, so let's get our usual friends. Whoops, capital log. It's like an excited beaver. Log. Okay, and we're gonna get assert equals require assert, and we're gonna want to parse the input. So when we parse input, we're gonna get back three things. We're gonna get back rules, an array of rules. We're gonna get back our ticket, and we're gonna get back other tickets. So let's just sort of like write what that would be. Parse input, and we're gonna want rules, rules, ticket, and other tickets. And that's going to be equal to parse input. And then what we can do is we can log. Let's just start with logging rules for now. So here comes the fun part. We got to write parse input, and that's going to take in a wall of text, as is typical. And we know we're going to be returning these things at the end. So let's just put that in. We're going to return that. So now what we need to do is we need to fill in this middle bit, which is returning text into these three things. And let's just start with rules for now. So what we can do is rule diffs. Let's split this. I know that there's two blank lines and some optional title text between the sections. So we're going to say rule diffs, ticket and tickets, or other tickets, other ticket, defs, ticket, def. And we're going to split the input. Split here equals text dot split on two new lines, because we new line twice. And we're going to also have a bunch of just word characters and another new line. So that and another new line. So that will be what we get. So let's just try this and see if this gives us here log here, log input split that. Let's see what we get. So this gives us not what we're looking for. Oh, of course, because yeah, this we're not splitting. That's we want to split on our regex. I guess, can we do that? Can we split on our regex? I guess we'll do input match or. So this is a good question. If we want to split, we want to. I guess what we want to do, we could pull out. Let's just split on the new lines for now, and then see what we get back. So this gives us this, that, and that. Okay, so that gives us these definitions, and then what we're going to want to do is we're going to want to remove the first line from your ticket, and then have the defs there. Okay, so got the split, and we're going to. Okay, rule defs is fine. I guess rule defs equals rule defs dot split. So we'll just handle each one of these independently. So we're going to split that on new line. And then ticket def is going to be same thing. I'm going to split it on new line, and we're going to chop off. We're gonna discard the title. So title ticket def equals ticket def split, and then we're going to do the exact same thing for nearby tickets, other ticket defs. Oops, we're going to ignore the title, and then so that should give us just arrays of values, I think. And then, so we're going to have to do more stuff to the rule defs because, you know what, maybe we should just get rid of defs. So rules and ticket. Okay, and then we'll have rules, ticket, other defs, and we can just log parse input. So I'm just doing this so we can like get some output. So we're going to have class, row, seat. This is our ticket, and other tickets. Let's try that. There we go. So we got our single ticket, and then we got other tickets, which is an array of these values. Okay, cool. So we've got basic information out of here, which is okay, but it's not very useful yet. Now what we need to do is we need to turn these rules into actual executable rules. So that's going to be interesting. I guess the other thing we're going to need to do is we're going to need to be able to split these apart into values. So let's do that. Let's do ticket equals ticket dot split on a comma. I guess we can do single quotes. And then we're going to map it through parse float because it's always a number. Okay, and then cool. So that gave us that, and then we're going to do the same thing for other tickets. Other tickets equals other tickets dot map ticket. See, we're kind of repeating ourselves here because we're processing ticket the same way. So we could actually split this out into parse ticket, and we could just do that here. Parse ticket equals, and then we can map this through ticket equals parse ticket, and then we can map this parse tickets. Let's see if that works. It does. Okay, cool. So that way we're not, I mean, we can actually have this up here. It doesn't really matter. We can also define it inside here so it doesn't pollute the global namespace, but I don't really care. I think this is fine. Cool. So then we are going to have to do something similar with rules. But rules are a bit more complex. I think what I'd like to do is I'd like to create a class for a rule. And the reason why is because they're a bit more complex than just sort of an array of numbers. So I think it bears having a class just so you can do things like you can record the name, you can have an array of ranges that you can apply. You could have a method where it takes in a ticket and it validates it. So that's what I think I'm going to do. I'm gonna make a class rule, and it can take in this input string and parse it. Constructor, and this is going to take in a string. And that is going to assign, basically it's going to do string dot match. And we're going to have, so we're going to have a word or a space. Is a word in a space? I don't know. Let's find out. I always forget that kind of thing and I have to look it up. We're going to have a series of word characters followed by a literal colon. Followed by a space, which you can just have as a space. And then there's going to be a series of, we're going to have digits and dashes. A digit and a dash plus. And then followed optionally by or. Actually, let's take a look at the actual input. All of these have ors, and let's see if the actual input, it always has an or. So it's always two ranges, always has ors. Okay, so that makes life more difficult, more easy for us. So we're gonna have digit dash or digit dash. In fact, we could actually just parse out the digits themselves. And so what I mean by that, I'm just going to anchor these. What I mean by that is we could actually, since it always has, this same thing. There's the name, colon, and then we've got one group of digits, a second group of digits. So that's like the first range beginning and end, and then the last range beginning and end. So we could just pull those out and say, okay, so we've got one or more digits, dash, one or more digits, or, and then we can do the same thing again. So this would give us like capture groups 2 through 5 would always give us first last of the different ranges. And of course this should be a capture group as well. Cool. So let's just try this down here. So let's take one line of our things like this class, and let's try to match this and see what we get back. So this gives us class 1, 3, 5, 7. Okay, let's get a bit fancier. 33 and 35 to 87. Make sure. What just happened? There we go. Okay, let's make sure. Okay, it's able to get multiple digits. Now, what about multi-word class names? Class name with spaces. And we'll run that. It does not. Okay, so we're gonna just want word character or space. And that will be class name with spaces. Good, so we've got our class name with spaces. We got 1, 2, 3, all right, good. So, cool. This is going to return something we don't care about, which is the entire match. So we're going to throw it away. Then it's going to give us the name. It's going to give us actually, let's just parse them along into here. So that's going to give us the name. It's going to give us range 1 start, range 2 start, or range 1 end rather. So let's just, yeah, okay. Range 1 start, range 1 end. Okay, this is a bit easier to read. And then we'll have range 2 start and end. Okay, and now what we can do is we can just assign name right away because we don't care. And then we want to create ranges. So ranges equals, so these are going to be the ranges that we want to check it against. So what we can construct just we can construct literal arrays of valid values. And how big would that be? Let's take a look at our input. None of these numbers are crazy large. So I mean, like, they go up to the better part of 1,000, but I'm not too concerned about having those ranges be too big. So we're going to start with empty array of ranges, and then what we're going to do is we're going to say range 1 equals range 1 start. This we should actually parse as a float. Parse float up to and including range 1 end. Okay, so this is going to give us range 1, and then range 2. It's going to be the same thing, but with range 2. So these are going to give us, and I mean, really, we don't need to store these in a variable because we always know there's 2. So let's just put them up here. Cool. So now we've got our array of ranges. So let's construct some of these rules, and we'll see rules. Okay, so what we're going to do is we're going to map over the rule definitions, and we're going to pass them into new rule, and we're going to see what we get back over here. So rules equals, what do we have? Rules dot, have we already split it? We've split them. So we're going to map, and this is going to be the def, and we're just going to make a new rule with the def. Right, and this is a function. Okay, so cool. We've got rule with the name, row, seat, and this has our ranges. Cool. So we're going to need to have a valid function that takes a ticket. And this ticket is really just, right now it's an array of numbers. And we're going to say for num in ticket, and we're going to go over our ranges for range in ranges. So what we want to do is we want to make sure that it exists in at least one of these ranges. Every number in the ticket exists in one of the ranges. So, and we also know that there's always 2 ranges. So what we can say is, unless num in ranges 1 or 0, or the numbers in range 1, which is the second range, we're going to return false. Otherwise, return true. Cool. So that's our valid function, I think. So we can actually try that. We can say, but that's not going to give us the output that we want. That's just going to tell us that it's not valid. The output that we care about is we care about what the invalid fields are. So we're going to need basically invalid fields, and that's going to take in ticket, and we're going to do the same thing. So for num in ticket, and we're going to do this same thing. We could pull this into its own function, num valid, and this is going to take a num, and this just does this. So return false or true. So this is going to say, we're going to say if num in range 0 or num in range 1, return true, else we're going to return false. Okay, so we can just say at num valid, at num valid, num. This is not what we wanted. We wanted to say, okay, return. Well, I don't know that we're going to use valid yet, so let's just remove it. So we'll find out if the number is valid. So for num and ticket, we're going to have a return. I guess there's only ever going to be, this is going to be give us first invalid field, I guess, because we'll find an invalid. So for num and ticket, we'll call num valid. We'll return num unless num valid num, and then otherwise we'll return true, or I guess true, false, because there's no first invalid field, or null maybe. Okay, I guess we don't have to return anything. Okay, so first invalid field for ticket, so we can call that here on these rules. So we got these rules. Let's log the rules, make sure that we still got them. Okay, so for rule in, or for ticket in other tickets, what we can do is we can, or I guess we can map these. For right now, let's just log them. So log t dot, or and for rule in rules, yeah, what we want to do is we want to find the first invalid field. So rule dot first invalid field for ticket, and we'll log that. So this is giving us a problem. Ranges is not defined because it's ranges. Okay. So this is saying that the first invalid field, so for ticket 1, oh, this is giving us 73, 47, 44. This is giving, like, it's telling us that everything's valid. Is that because I did that? No, it's not. Okay, cool. So first invalid, so for num in ticket, return num unless the number is valid. So return true if num in ranges or num in ranges 1. Otherwise false. Okay, so let's take a look at that. Num valid. So let's just take a look at the, first rule. Make sure this is working. Rule equals rules. I guess we don't need to set that to a rule. And we'll say num valid, num valid. And what is the first rule? The first rule is 1 to 3, 5 to 7. Let's make sure that that's actually the rule we're talking about, class. Okay, num valid, and we're gonna pass in 3. That should be true, and it's false. Okay, so if num in ranges 0 or in ranges 1, can rewrite this as return true. So these are the cases where it's true. So let's log num and range is 0, and then let's log num and range is 1. Oh, so this is up to and not including, maybe. Yeah, there we go. That was that. Okay, so this is up to and including. The other one was up to not including. Cool. Okay, so let's see if this now works. So it's saying 47 is invalid. So maybe what we're doing is we are doing this wrong. So nearby tickets. So for example, if any of them, so 47. So we want to know if it fails any of the rules. So this individual num valid thing, this is going to return, right? Okay. So what we want to know is if it fails any of the rules. So what we want to do is first invalid field. Yeah. Okay. So if it fails any of the rules, then we want to know. So we basically want to get back a list of invalid numbers, which is what we're doing here, except is this a list of invalid numbers or is this a list of valid numbers? This is a list of invalid numbers. I guess what we should do is we should actually give back a full list of invalid numbers rather than the first invalid number. Okay, and let's bind these two to this, because that way they'll never lose that binding. Okay, so log rule first invalid field. So it's saying 47 is an invalid field, and that's because it fails one of the rules. Oh, I see. So it's valid if it's in range 1 or range 2. This is for each of the rules, but we want to know if the ticket. So we've got this backwards, right? We're testing the rule with a ticket, but what we really want to do is we want to know if the ticket violates any of the rules. And so maybe we should create, you could create a ticket class, or we could, yeah, okay. So maybe what we should do is we should be checking validity. And that's sort of what we're doing here, I guess, is we're trying to get the first invalid field in any rule. But we want to know if any of them are invalid. So the question is, why is 47 invalid? So it says 47 is invalid because it violates one of these rules. Okay, start by determining which tickets are completely invalid. These are tickets that contain values which aren't valid for any field. And 47 is valid for that. Okay, so for rule and rule, so we want to find out, so for T in other tickets. Okay, so for value in T, what we want to do is, okay, so we got this backwards, that's why. So for value in T, what we want to do is we want to return, I guess, val. Oh, we're not returning. Let's just say, so invalid values equals that. And then we'll say dot push val if. And now we need to check all our rules. Rules dot map. So we're gonna need to map that it's valid. So we do need this valid rule, and we are going to, or I guess num valid is the one that we need. So we need to map on num valid for rules. Rules dot map rule, and the rule dot num valid for val. Okay, and we want to know if not all of these are true. And I think underscore gives us all. So let's import that. All equals require underscore. So this should give us all, or is it all or every? Let's find out. Underscore array all. Yeah, I think it is all. Here, arrays. Let's just search for it. All. Yeah, it's every. Okay, every alias all returns true if all of the values pass the predicate truth test. Okay, so we can actually remove. So what is this? List predicate. So we can say all rules, and then we don't actually need map. We can pass this into. Okay. All right. So every, and this is going to be destructuring every. Cool. So every rules. So every entry in rules. This rule passes this test. So this is a bit confusing. Okay, so for value in ticket, we're gonna push that, and we could actually just say tmap val dot map val, and then, or I guess t filter. Then we don't need this. So let's log that. Okay, that's angry. So invalid values. All right. So okay. So we want to filter out. We want to keep the opposite of if all of them pass. So 7.347. That's weird. So 7.347, that's just our first ticket, right? 7.347. Yeah, so maybe this isn't working. Okay, so let's go back to invalid rules and we'll push them in. And then we'll return or log invalid values. So this is giving us the same thing. So let's check this out. So not every rule. So all our validities equals map. We'll just map it like this. And if not every validities. So okay, cool. So let's log validities here. So this is giving us true, true, false. And I guess what we want is we want to know if maybe it's not every, maybe it's any that we want, because we want to know if any of these. So rules map num valid. Yeah, we want to know if any validities. So if not any. So yeah, so 4, 55, and 12. Those are the things that we care about. Okay, wow, that's kind of a mouthful. Look at this. So let's give this method a name. This is find invalid values, and that's going to be, it's going to take in, what do we take? Tickets. It's going to take in rules and tickets. Rules and tickets. And so what we can do is we on valid find invalid values. Invalid values equals find invalid values, and we're going to pass in rules and other tickets. And this should not be here. This should be down here because we need to pull this in. So every and any. So we really only used any. And what we could do is we could write our own any. That would be pretty easy. But I don't I'm not really going to be bothered to do that. I'm just going to use the underscore one. It's convenient, it's well tested, I'm happy with it. Okay, so for T in, what do we have here? Tickets and rules. Rules, okay, cool. And instead of logging them, what we'll do is invalid values. All we care about is invalid values. So we'll put them up here and then we will return them. Cool. And let's see what that looks like. Log. Whoop. So that failed. Find invalid values is not defined. Find invalid values. Oh, because this is indented too far. So that's actually looking like a class method. Okay, so we've got a log somewhere in here. There we go, validities. We don't need to do that. There we go. So this is going to give us these. And what do we want to do to find the answer? What we want to do is we want to add them together. Yeah, okay. So ticket scanning error rate. So some array, we have this already. Okay, let's grab this one, the most recent one from day 14. So here's some array. And what we want to do is we want to assert that 71 is some array, find invalid values. And that works. Okay, cool. So this is sort of what we are looking for. And I guess what we'll want to do is we'll want to make a method that takes in the input and, or at least the parsed input. So rules, ticket, other values, and we'll want to find, what is this called? The ticket scanning error rate. Error rate equals, and this is going to take rules, tickets, other tickets as the input. And it's going to do this. Some array, find invalid values, rules, other tickets. Cool. So this is going to be an array. Ticket is going to be a string, or I guess that's also an array. It's an array of numbers, and this is going to be an array of arrays. Cool. So what we want to do is we want to find the error rate, and we will say find the error rate of parse input. And that works. Okay, cool. So now what we want to do is we want to find out what it is for our input. So we can log error rate, parse input, acquire input. And we're going to need a file called input for that. Input.coffee. All right, module.exports equals. And we need to collect our input from here. Cool. Let's see if it works. Cool. Bam, exploded. Object null is not iterable. So looks like it probably failed to parse something. So line 76. We can get rid of that because we're not using it for now. So it's not liking one of these rules. So that's interesting. So let's try this and then catch by logging whatever the string was. And we'll say error string. I guess we don't need that. Okay. Departure location. So it's angry with these. Oh, okay. I remember. It's because we had a word or a space. There we go. Okay. Cool. So that's nice. And we got 23044 is the answer that we got. So let's put this in. That's the right answer. Sweet. Okay. Continue to page or part 2. So let's grab this entire thing, put it into here, and now let's read part 2. And we'll just paste this in here. Cool. Plain. Oh, this is our input actually, isn't it? Okay. Cool. So let's read it. So now that you've identified which tickets contain invalid values, discard those tickets entirely. Use the remaining valid tickets to determine which field is which. Okay, so this is going to be a two-parter. One, we're going to want to filter out the invalid tickets. And 2, we're going to have to figure out what fields are what. Okay, so that's interesting. So using the valid ranges for each field, determine what order the fields appear on the tickets. The order is consistent between all tickets. If seat is the 3rd field, it is the 3rd field on every ticket, including your ticket. For example, suppose you have the following notes. Okay, so based on nearby tickets, yeah, this makes, and then what are we gonna get? Once you work out which field is which, look for the 6 fields on your ticket that start with the word departure. What do you get if you multiply those 6 values together? So departure, departure, departure. There are 6 fields that start with departure. Look for the 6 fields on your ticket that start with the word departure. Oh, okay, there. I was just scrolled down. Okay, cool. That's neat. All right, so how are we gonna do this? So I guess what we'll want to do is we'll want to solve this maybe in a similar way to how we solve Sudoku. And that takes sort of like the current state. So you go through and you say, okay, this one, the first field for this ticket, the first field could be class because it matches. Or the first field could be row, or the first field could be seat. So for each one of those, you sort of like spawn a new state. So in this case, the first one, actually you'd want to evaluate all the tickets. You'd want to make sure that it's true for all of these. So it could be class, it could be seat, but it could not be, or it could be row, but it could not be seat. So, and then with 5, 0 to 1, 4 to 19, 0 to 5, 0 to 13. So the first one here could be class or seat, but not row, because 15, or no, it could be class or row, but not seat, because 15 disqualifies it. So what you would do is you would split reality at that point. You'd be like, okay, like we'll go down this one branch where we've assigned class to the first column, and then you would have another branch and row to the first column, and so that is now no longer a column that you can assign, and you go down each one until you get stuck in a dead end. And so we're going to do probably something similar to that. The first step is removing tickets that have invalid values. So let's focus on that part first. So, and eventually we're going to want to assert that, right, we're going to want to then find the columns for the ticket, and then we are going to want to multiply them together. Okay, we'll worry about that later. Right now, let's just get rid of the invalid tickets. Excuse me, my nose is a little dust reactive today, which is really annoying. So find invalid values. So I guess what we want to do is we want to find invalid tickets. This is just for finding invalid values. And what we want to do is we basically want to do remove invalid tickets, or filter invalid tickets. Or I guess we want to just get the valid tickets is what we want to do. So that's going to be okay, tickets.filter, and that's going to take in a ticket, and we want to know basically if any ticket or if any rule for Valenti. So for value in ticket, so this is if not any rule. So we want to say if not any rule, rather than just pushing the value, what we'll do is we'll say return false. And then otherwise we'll return true. So valid tickets, this should give us just the valid tickets. So this should give us one ticket. So let's log it. Valid tickets, and it takes rules and tickets. You know what we could do is we could make them all take the same rules, ticket, other tickets. We could make them take all the same thing like this, because that would be easier than having to destructure it. But whatever, I'll just destructure it. Okay, rules underscore, this is our ticket, tickets equals here, parse input. I guess I can just say tickets in this find valid valid tickets with rules and tickets. We'll see what it is. So true is what it gives us. Oh, there we go. This is right. This is filter. Okay. So these are these are actually the invalid tickets, not the valid tickets. So because it's filter, not select. So let's select the ones. Okay. Tickets select is not a function. Okay, let's do the opposite then. True, false. So nope, that doesn't work. I'm surprised that JavaScript array select. Script array select. Array select in JavaScript. There's array filter. It is not standard ECMAScript. Array filter is now supported across all major browsers. They're just saying to use underscore. Okay, well, let's use underscore because we've already got underscore. Filter, actually, let's get select. So where are we? Valid tickets. We're going to select tickets, and then we're going to add a ticket. So that's saying, okay, so if not, so if any are valid, so let's do this, not valid. So we'll say if any, we'll just return that. In fact, so val. And this is going to, we're going to want to know if any, so we're going to want to map this t.map val. And then this is going to give us any. So this is giving us the, so we're going to select tickets. We're finding any invalid tickets is what we're going to do. So we're going to filter. Let's use filter instead of select. Filter. No, that's, oh, this is the values that we're getting back. Hold on, I'm confused here. So valid tickets. So we've got the tickets, and let's select if they're valid. And I think we had valid, but did we delete valid? I guess because we never used it. valid. I guess what we want to do is we want to find invalid values, and we want to say, if not, so valid tickets. So select tickets, and in the ticket we want to find the values. So if any of the values violate any of the rules. Okay. So this is incorrect. 3, 9. Oh, this is just our tickets from input. Let's take a look. 3, 9. This is giving us all of them. They're all invalid. Oh, this is a different input than we're used to as well. So let's actually test this on the previous input, because that's what I was sort of thinking, is that we should have only one. So let's just test this value here. Okay. Okay, so this is giving us, it's still giving us back all of them. What we should have log valid tickets, rules tickets, so valid tickets. So I guess what we can do is we can add invalid, and then this is going to take in a ticket, and it should always be like that. And then so for rule and rules, or not rule and rules. Oh, this is just going to give us, yeah, like I feel like what we should have done is we should have made a ticket class, and maybe that would be more natural to think about this. So let's do that. Let's just class ticket, and we'll have this constructor where we have values equals, and this is going to be an array, and it should already this should already be split into integers. So let's define valid by taking rules. So, and this can be all valid. And we can say rules every. Rules, and then how do we, what do we want to do here? We want to say, okay, so rules is going to be an array, and we have values, which is an array. We want to make sure that every rule is valid for every value, right? I guess, or what we want. So error rate, find invalid values. Rules, other tickets. And this just tracks the invalid values, which we don't care about anymore. What we care about, okay, so yeah, let's just take a look at the question again and see if we can sort of like reframe it. So we've got a ticket, and we want to know if a ticket violates any of the rules, or all of the rules. Yeah. So if so not every rule's valid, or num-valid. So every number on the ticket should pass every rule. Is that correct? Or should pass every number on the ticket should for every rule. every rule. So we want to make sure that not all of the rules fail. So, okay, so rules, we want to make sure that the rules that true is included in rules map, and we're going to pass that in. It's going to be rule rule.num valid, and then this is going to be num, and this is going to be for num in values. So we're going to return false if unless true in. Okay, so okay, so this is going to say that the ticket is valid according to these rules if for every number in the values we're gonna say it's not valid unless there's at least one rule that passes. Okay, so it's gonna be valid t's equals that, which I think we had before. Okay, and we're gonna unless true invalidities. Okay, so and otherwise we return true. Or we can just true. So it's not valid unless there's at least true in the validities. So let's test this. So ticket new. So for okay, this whoops. All right. So let's test this. Make sure. So I know that the first ticket is valid for t in tickets. We're going to say ticket, nope, this isn't Ruby, new ticket t, and we're going to, oops, I guess we can just say t equals new ticket t, right, and then we're going to call t dot valid on it, and we're going to log t and t dot valid, and then we can remove that. So this should give us the first one should be true and the rest should be false, and they're all false. So it's saying that this one is not valid. Oh, because we need to call with rules, that's why. Valid rules. We need to validate against these rules. So true, false, false, false. Okay, cool. So now that we have this method, this ticket valid, what we can do is we can filter by ticket values. So valid tickets are going to be t, select tickets t, and we can say t equals ticket new ticket t, and then we can say t dot valid rules, and that's going to select these. So valid tickets in this case, what we can say is valid tickets, and it's rules tickets, so log those, and that should give us back just the valid tickets, which it's doing. Okay, cool. So that's given us, so this should give us a new set of valid tickets, which is from our input, which is 3 of them, and that's all of them. That's all the tickets. So I don't know if I guess they're all valid. Maybe this was working the whole time. Okay, using the valid ranges for you, determine what order. Okay. Now that you've identified which tickets contain invalid values, discard those tickets entirely. So did we just discard them before we got the input? I guess we did. Okay, using the valid ranges for each field, determine what order the fields appear on the tickets. So the order, so we're going to have field order. So field order is going to be based on the rules. So I guess what we'll do is, like, we probably don't need this stuff like sum array and error rate. Find invalid values we don't care about anymore. Rule first invalid field, I don't think we care about anymore. We just care about whether a number is valid. So is it still working? Yeah, okay. So let's get rid of all the cruft that we don't care about right now. And we can add it back if we need it. Okay. So these are the valid tickets. Okay. Parse input, parse ticket. What we could do is, I mean, we could create a ticket object out of these. And change our function here. Was it valid tickets? Because right now we're kind of mapping these over. So let's do that. Parse ticket ticket, and parse ticket ticket can new ticket. Okay, so that's blowing up. Value split is not a function. Let's try that. Okay, so this is giving us these tickets, these ticket objects now. Okay, cool. Neat. And in fact, I guess the ticket constructor, rather than giving us values, what we could do is we could take in just a string, and we could say values equals, what is it? String split map, like that. New ticket, ticket. Cool, and then new ticket, ticket, values equals string. Oops, like that. So this is failing, string split is not a function. It's not. Okay. What do you mean it's not a function? String split is not a function on line 55. It's absolutely a function. Why are you like this? Equals. So string, so ticket. Oh, you know what? Is this so parse ticket, this is probably giving us, this is an array of values. So I think parse ticket we can probably get rid of. So tickets, other tickets. And then this is going to be ticket equals other tickets map t new ticket t. This is still upset. String split is not a function. Well, let's take a look. Line 51. Line 51. Okay. So let's log string and see what they're giving us back. So let's log type of string. So we're getting an object at some point. Oh, it's because we're constructing a ticket somewhere. New ticket t. Yeah, which we don't need to do. Right, that's why. Ha 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 ha. Okay, so this was all fine. We can put that back. Get rid of this log type of string, and we can say equals string split map. There you go. I find this more readable. Cool. Neat. So other tickets. Okay. So we got our tickets. we have a method to find out if they're valid or not. We got these rules. Have num valid, and then valid tickets is going to give us just select the tickets for which the ticket validates against the rules. Okay, so what were we even doing again? I forget. What we want to do is we want to, okay, so now comes the fun part, which is assigning the values. So we can determine if a ticket, so we can determine if a rule is valid based on a number. So what we want to do is we want to figure out for all of our rules. Okay, so we're gonna have a rule map, or I guess a rule map. I don't know. This is gonna be like an object, and or I guess it's gonna be an array. We're gonna have an array, and right to start off with, it's just going to be nulls everywhere because we haven't assigned any rules. And basically what we're going to say is as we figure out that the first value in a ticket can be a specific rule, we're going to fill that in like this. And then we're going to go until these are all filled up, or until we get to a point where we can't fill anymore. And then we're going to back out. So, you know, and maybe this is going to be like rule 3 or whatever. And if we, and then we need to generate this rule map is what I'm saying. So rule map is going to take all the valid tickets. It's going to take all the rules, and it's going to take the current state of our rule map. So let's find rule map. So this is going to be a function. We're going to take all the rules, or maybe all the rules we have left. Maybe we'll do tickets first. Tickets, rules, and then the assigned rules, or the map. So this is going to be the rules, tickets. So it's just going to get the tickets and the rules to begin with. And what we're going to do is we're going to go through the ticket values, I guess. We'll go through the rules, and we'll find the first go through, I don't know where we're going to do what we're going to start with. Okay, so we're going to go through the rules, and for each rule, what we can do is we can find the first value, or the first index in a ticket. I guess maybe what we should do is we should do tickets dot, or I guess the first ticket values for val index in tickets values. What we want to do is we want to find out if a rule applies to all of those. For rule in rules, and what we want to do is we don't even care about this val. What we want to do is we want to find out if the rule applies to every ticket in that value. So if, I guess we want to say if every tickets, and we want to say rule num val. So we can test the rule. So we want specific value. So values is going to be a string. So if every tickets, and this is going to be ticket, and we can say ticket dot values index, values index, and we want to say rule dot is that num valid. Okay, so we're gonna do that. So if every, then what we're gonna want to do is we're going to want to remove rule from rules, or rule without rule, or rules without rule, and we're gonna want to add it to the map. So we're going to want to rule map okay, so this is going to be recursive, and we want to return rule map. We want to return map if rules dot length is 0. So when we run out of rules, we want to return the map. So map equals rule map, and so when we call rule map again, so with if every tickets, what we want to do is we want to call rule map again with tickets, because it always takes tickets, and then we want so new rules equals r for r in rules when r isn't rule. So this is when, so we're just getting a new copy of the rules, and then we want to do map. So what we want to do here is we want to say new map equals let's create a copy of map, and then we'll say new map index equals rule. So that's what we're going to want to do. We're going to want to call this. So we're going to get map back. I guess we don't want to assign it to map. I'm going to say if if the result, if result, we're going to want to return result. Oops, return result or res. Whoops, there we go. Return res. Return result if that, and otherwise you'll just keep going. Okay, so rule map, let's just try this. I don't know if this is actually going to work, but let's just give it a shot. So we want to rule map tickets rules map. So we want valid tickets and rules, and then map is just gonna, I mean, map is not gonna exist on the first pass. So this gives us the rule map back, which is row class seat. So it gave it back to us in a different, so that's interesting. It kind of worked. And I guess all we really care about is the number, not the rule. So the map that we get back in rule map, where's rule map? Rule map can be rule. Okay, so new map rule dot name. So row class seat. So Okay. So this works so far. I wonder if rule map will work for the input. So let's see if, oops, require input, parse input, require input. Okay, and then we'll do this, rules ticket equals, oops, so let's just see if it blows up. And it does, it gives us a bunch of undefineds. So we know that that's not going to work. So for, it's going to row seat zone 5 empty items. So we need to keep working on this because we know that it doesn't work for every case. So we return that. We return map if rules length is 0. If rules length is 0. Yeah, okay. So we never got that for value index in ticket.values. And so for rules, for rule in rules, I guess what we can do is we can say we're just looking for the num valid for when, oh, we want them all to be for rule and rules, yeah. When rule num valid, I guess when, oops, rule not invalid val. And we can do that. Nope. We can't do that. Okay. Row class seat. Well, I wonder if row class seat works. Is that one of the things that they said? So based on the nearby tickets, your first position must be row, the second must be class, and the third must be seat. So that did work here, row class seat, and it didn't work here. So row seat zone. So why is that? What do we do here? So what we're doing is we're looping through all the ticket values for value in tickets. So really all we're doing is we're looping over the index. And we're seeing if it satisfies the index, then we go further, else we go to the next rule and see if that rule satisfies all the indexes. And if it doesn't, and okay, we're returning result. So I guess what we're doing, so for rule and rules, so we should be handling the false case. Okay. Wash and break. All right. So All right, what were we doing here? We're making this recursive function rule map. So this, let's just think about this. This return if we win. Okay, if we're done. If we're done, we win. If we're done. And if we're not done, for value and index in ticket values. So, okay, this I think this is backwards. What we want to do is we want to go through the rules in order. So for each rule, what we want to find is we want to find the first index in ticket values, and we want to find out I guess what we want to do is we want to make map an array of the same length of ticket values. Okay, so map, let's not do that, or equals to new array, and I think like that, you can do that. Is that what we do? Let's try it. Cool, so let's comment these out for now, and we'll say log new array 6. I think this is how you get a, what is this? It's unexpected indentation. Okay, here, let's just comment that out for now. 6 empty items. Okay, yeah. So 6 values length. Okay. Well, there you go. So, okay, let's go back to logging this. So we're going to create the map to be this length. And then what we can do is we can go through the map for entry in index in map. Oops. And what we can do is we can say, okay, so now what we really want to do is we want to do when not entry. So basically we want to try and fill in the empty spots in map. And then so for rule in rules, so now for every rule that we have left, let's try and fill this spot in the map. And then so what we're going to want to do then is we're going to want to say we want to make sure that the rule works for that index. So what were we doing for every tickets? So every tickets rule invalid, and then the value of ticket at that. So we want to say if all the tickets pass at that value, then what we want to do is we want to recursively call it. And actually this is going to be every tickets for rule and rules. Yeah. So what we'll do is we'll do this stuff. So we want to get a new copy of the rules without the rule that we're working on, and then the new map is going to be map, and then we're going to put in this rule name. Okay. And we're going to return the result if that is true. Otherwise, what we're going to do is for entry, so for rule and rule, if that else we're going to return false. This might be exactly what we had before. And who knows? Let's find out. So otherwise we're going to return false, which is going to not satisfy this condition. It's not going to return a truthy value. Okay. So this is just giving us false. Rule map false. So let's see what this is doing. So for rule and rules, and we'll just log all tickets passed in index IDX for rule name. Let's close that. So it's not even going in here. Or entry when not entry. Log map. Okay, 3 empty items. Tickets 0. Values length. Okay, so that's 3. Length 3. Okay. Return map if rules length is 0. Log still here. Okay. And then for entry index in map. So map is an array. When not entry. And then log index. So, oh, this is returning false, right? We don't want to do that, I don't think. Okay. So row class seat. Okay, and then what if we do that? So this does a bunch of stuff, and then oh man, I gotta turn off this logging. Shit. I think I killed Sublime again. I'll give it a minute. Hot damn. Okay. Yeah. Let's see if I can just kill the node process. Node, please die. There we go. So let's remove some of these logs and see. Okay, row class seat, and it's looking for. I guess it's looking for the next. It's looking for the thing down here. It's looking for the rule map for the valid tickets in the input. Okay, so it seems to be taking a while. So let's give it another few seconds, and then we'll kill it. So how could we speed this up? Force quit. Let's log the index. So it seems to be going. Yeah. Okay, let's kill node. It seems to be kind of just stuck. Force quit. And then return res if. So we return the result. So if a rule map works, okay. So if it works all the way along the line, then it will return. How many rules are in the input? I guess that's the real question. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we got 20 rules in the input. So in theory, those 20 rules, it could be a lot of combinations. It would be like 20 times 20. Or no, it would be more than that. It would be 20 to the power of 20. I don't know. That's, well, it's a lot. Anyway, 20 times 20 is only 400, so it would have been done that a long time ago. But or it'd be 20. It would be 20 factorial is how many combinations there would be. It seems to get up into the teens pretty quick, and then it just sort of like runs out of steam. So how could we make those faster? So right now, what we're doing is we're checking to see if every ticket is value for a particular rule. If every ticket is valid. So I guess what we could do, because this is evaluating every ticket for every rule, what we could do is we could say if any ticket is invalid, if and then, so what we do, if tickets, I guess for T in, we could continue. For T in tickets, continue if rule num valid. Okay, so we could try that. We could continue that, and then we could do that. So let's try that and see if it's faster. Let's see if it still works. Class row seat, is that what we want? No, it's not. We want, what do we want? We want row class seat. So this, so continue if rule valid. Or I guess we want, do we want break? Class row seat, yeah, okay. So class row seat, and that's what we want, right? No, it's row class seat that we want. This did nothing. Continue class row seat. So I guess what we could do is we could do tickets dot map t, and then we could continue. Or I guess what we want break. Legal break statement. Now we do want continue, because we want to continue here, but we do. Can we continue twice? T in tickets. Yeah, no, it's continue. Let's try that. No, I didn't like that either. So continue. This isn't going to work. So what we really want to do is we want to move to the next iteration of the rule loop. I guess what we can do, so for team tickets, okay, so what did we have originally? We had any. So I guess what we really want to do is we want to find. So if find not valid. Want to continue if find. Otherwise, we'll do that. So if we find an invalid ticket, we want to continue. So this is also find is not defined. Oh yeah. Can we, is tickets dot find? Can we do that? Yeah, we can do that. Okay, cool. So this should be faster anyway, but of course it's still pretty slow because it's kind of getting stuck. So let's kill that. No, stop, force quit. So this is like trying different combinations, and it's failing faster now. So if it finds an invalid ticket, not Invalid. So if it finds an invalid ticket, it will continue to the next rule. And it's got to try all the rules. And it's going to do that for every entry. So let's remove the log and see if it finishes. So it's giving us row class seat for the first one. Is that what we want? Or no, do we want? Yeah, it is what we want, row class seat. So I feel like this should find it eventually. It's just taken a while. So let's see how many loops we're doing. Equals 0. Okay, map loops equals 0. And say loops plus equals 1. And then we'll log. Oh, this is going to log every time. Yeah, log. This isn't even what we want. What we want is we want loops equals 0. Just do it here. We'll do loops plus equals 1. And we'll log loops if loops mod 1000 is 0. So I guess unless, okay. Yeah. So here we go. So we're testing a lot of these. And what do we have? We've got 20 rules. So what's 20 factorial? What do we have to get up to? Shit, a very large number. Okay, so this isn't gonna work. Let's log map. Let's log the state of map. Log loops and log map. Join like that. So it's trying different combinations, and it's iterating. So it seems to have a common first, like, so it's come up to a rival station, and it's just testing every combination of these. I wonder if I could. Oh, this is doing the same thing that we did in another one, where it's going to just try the same combinations. So what we can do is we can throw in a cache. Cache equals that, and so the same rule is always going to pass or fail for all the tickets. The same, or checking a rule at an index. So okay, so first let's kill that. So we get the cache, and what we want to find is valid equals oops, and then continue, or invalid equals that, and continue if invalid. So this is tickets find that. So basically we're gonna check the rule at this index against all the tickets. So this cache, this is going to be our invalid cache. Cache rule plus index or equals to that. and then continue if invalid. So let's see if this speeds shit up. So it should start paying speed dividends soon. And yeah, we're already burning through a lot of these, so that's good. Okay, so this cache definitely helped. Is definitely helping. It's starting to move much faster now. Okay, so that's giving us. I mean, it's still not moving super fast. So what is this? This just checks a rule at an index. And that's what we need to do, I guess. It would probably go faster without the logs, but it's nice to be able to see. So it's still checking different values under departure time. I mean, we could just be doing this slowly, and it might just take a while. So rule plus index. So this should give us rule plus index. Oh, we want the rule name, not the rule plus the index. Okay, rule dot name. Yeah, let's rule dot name and index. So let's try that. We could also do yeah, this is fine. Let's do that. Okay, so 238,000. So we're probably, do we have 2 nodes going? 3, 4. So hopefully this will speed up quite a bit. So once it's checked a rule at an index, it should, oh, this is or equals. So this would that be false? Or equals. This should be existential, not false. And this should be not. Okay. Let's see if that. So we're still running 2 nodes, but that's fine. So hopefully this will speed up quite a bit. So we want to pass back in true or false. It seems to be going slower than it was before. So we're still constructing these. We're constructing these strings every time. So rule name index. What we could do is we could make a double array. So we could say a cache index or equals to that. And then we could say cache index rule dot name. Like that. Or equals to. And what do we want to find here? What we want to find here, so or equals, so what if we do, okay, let's stop this for a second. Stop. And let's kill this. Let's double check our assumption about the cache, because the cache would be the cache would return true or false. So if we have a cache and we can say cache of 1 or equals to false, or let's say, yeah, false, and then or equals to math.rand. Math rand? I don't know. And then we log C. What do we get back? We get 1 false. Okay, so it is existential. That is good. So now we've got this multi. Oh, and we're not passing the cache into the next loop. God damn it. Okay, well that's. I guess the cache would be passed by reference, so we don't really need to pass the cache into the next loop. So this is resetting the cache on every loop. So cache or equals to that, and then there we go. See if that's faster. Okay, so we need to not do these assertions now. Oh, I guess we can't do the assertions. Okay, so let's see how fast it goes. So 1,000, 2,000. So we're still looking at arrival station, and then it should give up on that soon once it figures these out, and then it should start speeding up, and then it should speed up more dramatically, more dramatically, more dramatically. So wagon, was wagon the last one? Yeah, okay, so now it's moving into zone. Oh, and you know what? We do need to pass the cache in here. Yeah, I don't know what I was thinking. Of course we need to pass the cache in. Bam. Okay, cool. So wow, it's getting it buzzed through a bunch of those. Class, duration, departure time. Yeah, wow, okay. We got a couple of nodes running here. Let's kill these. Force, quit, and let's change our log frequency to be much higher. So this went through a lot of them. Okay. Come on, Sublime. Sublime, why you like this? Memory, Sublime text not responding. Okay, well, I'm gonna kill Sublime and restart it. It's gonna open up my many Sublime windows. Okay, so the first thing I want to do is let's do the opposite way here. We want to cache, rule name, and then index, because that way it will only store this string so many times. Okay, so we initialize the cache for rule and rules. Okay, not tickets find. So this is going to give us a true if it finds an invalid ticket. So this is the invalid cache, and it's going to give us a false if it doesn't find an invalid ticket at that index. Cool, and it's going to continue if invalid. And then let's loop every 100,000. We can log loops and we can log the map. Okay, so let's try that. Okay, that blew up. Cannot read property is 0 undefined. Right, rule name. There's a holiday special in 15 minutes. Oh, I should really be joining that. I hope I get this done in time. Okay, so here we go. We are logging a lot, creating a big cache, and it's going through. What are we at? We're at duration. So it should probably start looking at duration or at the next thing from duration soon. Maybe what we should do is we should look every million. So let's cancel that and let's look every million. Okay, this is gonna take a while. What do we determine that the 20 factorial was? Is it 20 factorial? 20 factorial value. 20 factorial is a 2.4 followed by 18 zeros. I think this is gonna take a while. I guess what we can do is if it doesn't find one, we can continue right away. So continue for rule in rules, for entry. So we don't want to allow nulls. So all of this is useless because there's already a null. So where are we now? We're in return map. Okay, for entry index of map. Okay, for rule in rules. Are we? Yeah, we're removing the rule. Okay, continue if invalid. So it should be continuing to the next rule. And if it's rules and rule. And then we create our new map. And we add this rule name to the index. And I guess we'll want to continue. Why is rule net? So why are we having? Why do we have possibilities with these blanks? I guess because we just haven't filled them in yet, right? So that's what it's doing, is it's trying to fill them in. Yeah, I mean, I guess we'll just let them try and fill them in. So we're already, this is going to take so long. Oh man, and I have to go in 12 minutes. I mean, this could just take a long ass time. I think the logging is actually slowing us down. So what do we get to? 28. So 1, 2, 3, 4, 5, 6. So 284 million. So let's log every 10 million and see if it goes faster. In theory, it should speed up dramatically as it processes more because it should cache more. So that's 30. So 40 million. These should be getting faster. And they're not. So why is that? So we're initializing our cache if it doesn't exist. We are initializing the cache for a rule name if that doesn't exist, which it should. And then what we're doing is we are checking that at the index. So, and we continue if it is invalid. So I feel like these iterations should be getting faster, because really it's just trying to create a map where they're all true. Maybe we could do this the other way. Maybe what we could do is we could create a map for which every ticket is invalid, or for every rule is invalid. And then we could, I mean, that's sort of what we're doing. But we're doing it the other way. Like we're doing this recursively. So if we created an invalid map, then we'd only have so many options to check. So what would that look like? So invalid, so we check every ticket against every rule. And we get a map of what values that rule could apply to. I mean, that's effectively what we're doing here. Is we're seeing if any ticket fails, and if it fails, it's invalid, and we're caching that for that rule at the index. So I feel like this should just be getting faster and faster. Maybe it is 1, 2, 3, 4, 5, 6. So we're at 270 million iterations. But we might, I mean, we're still looking at departure time, class, like duration. So now we're still at like, we're still on the heavy end here. I have a meeting at 4 that I shouldn't skip. Whoops. Well, this would theoretically work if we let it run. What I could do is I could pause this and come back to it and just like resume the live stream. I wonder, maybe Toronto.js people have some solutions. What are people saying? I finished it and it was quite fun. No, this is they're talking about something else. I ended up doing the second half in VS Code. It wasn't that hard to code up this morning, but still faster than doing it manually. Part 2. I think they were talking about yesterday's, not today's. Yeah, anyone? I'm just gonna ask and see if anyone has completed day 2 yet. Anyone completed, or day 16? Day 16, part 2 yet? So I'm just talking in Toronto.js about if anyone's completed part 2, because absolutely there's no there's no harm in asking for help. Any tips? My solution is running for a very long time. There you go. Must be missing something. Oh, cool. So looks like Blake is going to post on YouTube. Okay. So let's go back over here. Cool. Yeah, so welcome, Blake, if you've joined us, and I hope you have. So basically what I'm doing is sort of like a similar idea. So we've got this rule map. We're trying to map the rule indexes to the ticket fields. And there's just a lot of combinations to check. So I am caching the whether or not a rule can apply at a certain index. So it's going pretty fast. Like we're at, was it 620 million, that the iteration 630 million. But like, I feel like this is going to go into the trillions or quadrillions or something. So yeah, not quite sure if maybe this should be better. I also feel like this should be speeding up as it iterates, and I'm not really seeing that. I'm seeing it taking about the same amount of time per iteration. So if you have the positions that each time is valid for, you can go through them and notice that one of the rules is only valid in one position. Oh, okay, so that's interesting. So that's a really good hint. So you could basically sort. You could sort by the length of number of positions that something is valid for, and that would give you a good idea. Okay, so that's a really great idea. So, cool. Okay. So thanks, Blake. I appreciate that. So that's a great tip. The great tip is that if one of these rules is only valid for one position, we'll want to just stick it in there and only bother trying that, and that can remove it from the rule set. And if another one is valid only in two positions, we may as well try those two next. And like, I guess the last thing that we want to try is a rule that's valid in virtually any position, because it wouldn't be helpful to try these rules that we know are only valid in one position in all of the others just to rule them out. Cool. So what we could do is we could, right, I guess what we want to do is we want to put the rules in order of how many positions that we'll also remove the position for that first rule from the rest of the rules. Yeah, so and that's where the real speed up comes. So what we want to do is, I mean, effectively what we could do is we could just sort the rules by how many positions they're valid for. So let's try that. So rules. So, okay. So this could be sorted rules equals, and it's going to take in rules, which is an array. And what we want to do is we want to sort by rules, sort by. We want sort by. Let's bring sort by in here as well. Whoop. Nope, sort by. I think we can actually just do this with JavaScript now, but okay, sort by rules, and we're gonna take in a rule. We're also gonna need tickets, and this is gonna be right. So, and what's Blake saying? So one's valid in position 2 and 5. Okay, I've got a meeting in 2 minutes. Yeah, thanks, Blake. Appreciate it. I also have a meeting, kind of a meeting in 2 minutes. That I should be at, so I'm just trying to get this done. Okay, so we're gonna sort them, and we're just gonna sort them so that it can eliminate the positions for the first rule first, and then it can get into the more ambiguous rules later on. So what we want to do is we want to say, okay, we actually want to, I guess we want to map, or let's say rules dot map, and we're going to map how many. So we want to find out if the rule, how many positions. So how many, so okay, so the num values equals tickets dot values dot length tickets. I guess we want the first ticket. Okay, so we're going to say, okay, rules, and we're going to map So rule, and then, whoops. I guess we can just do sort by rules, and then for index in num values. Yeah, what we want to do is we want to see if the rule is valid. So not tickets find. So now we're going to want to map these. And then we're going to filter. So we're going to be rules dot map rule, and then dot filter, and then that's the value. The value is if it, I guess, not. So this is going to be not tickets find, not rule invalid. So, and then we're going to just filter by value. And then, oops, length. Okay, so length. Okay, so we've got our rules. We're mapping them to find out if they are valid. Then we're filtering that number. Okay, and what we actually want to do is we want to rule sort by. We want to sort by instead of map, I guess. So sort by rules, and then rule. That's going to give us this. Right. So rule, we're going to filter. What are we going to, wait, what are we doing? Okay, oh yeah, for idx in, and then 0 num values. So we're gonna want to do that dot map index. And then we're going to find that, and then we're going to filter in length. So that's what we're going to do. So we're going to do sorted rules. So let's take a look at sorted rules here. So log sorted rules and rules and tickets, and see what we get. So this explodes. Rules is not defined because we need to parse the input. Okay, so yeah, this gives us seat class row, and then we want to do that with sorted rules. Sorted rules. Seat class row, row class seat. So this didn't. I guess what we could do is length, and then L equals that, and then log L, and then return L. So 231. So sort by is going to give us a B, or sort by should give us yeah, okay. So sort by 231, and then let's log rule name. So class 2 seat, so seat class row. So this is backwards. So we want to sort by, and then we want to actually reverse that. So we want to do sort by sort by num values minus L. And so that gives us seat class row is the way it should go in. Seat class row. No, that's not the way it should go in. Oh, because we're, right, num values L. Cool. So row class seat is the way it should go in. Row class seat is the way it should go in. Okay, so sorted rules and row class seat is what we're getting at. Okay, so let's try this. So let's log rule map and let's see how much faster that works. Okay, so, well, shit, that's giving us, it's giving us, okay, so the rule name, so it should be sorted in that direction. No, this is not doing anything. Sorted rules. Okay, so let's stop this for a second. So sorted rules. So when we log sorted rules here, and then let's stop these. Okay. So we log sorted rules. It should be coming back in row class seat, row class seat. So row should be the first one that we check because it has the lowest sort. So log rule name number values. So let's try this down here as well. And we'll get rid of that and see what we get back. So this is not good. These departure location seems to be valid for 19 of the 20 things. So that doesn't seem right. So we're mapping and then we're filtering. So filter, okay, and then length. I guess what we just want to do here is we want to select and then check the length, and that's the length. Apply select. Res equals that. Yeah. Okay, this is going to be range equals that. Range. L is not defined. Res dot length. Res dot length. So departure location, not a number. So res equals range. Okay, let's just rewrite this differently and just say for I in num values if. So what we want to do is unless, so if tickets finds an invalid one, we want to continue. Otherwise we want to res equals 0. Otherwise we want to res plus equals 1. I guess we could just say plus equals 1 unless it's invalid, and then we have res. So we're going to sort by this, and we're going to log rule name res, and then res. So this is the number of invalid or valid tickets. No, that's not correct. This is just going to give us. So if we find an invalid, then we don't do it. Okay, rule name res. So what does this give us? IDX is not defined. Where are we? IDX. Yeah. So what does this give us? Departure location is only valid in 1. A lot of these are invalid in 0. That doesn't seem right. Yeah. Damn it. Okay. I'm officially 10 minutes late now, so I'm going to have to cut this here. And then what I'll do is I will record the rest of this when I get back to it, because I feel like I'm very close to the solution. And then I'll post that. Yeah, anyway, I do apologize for cutting it, but I have to go, and this meeting is not recorded, so. All right, cool. So I will post the results and hopefully record the second part of this, or when I finish this up.